Hi, it's Mrs. Golding. I'm on the second page of our packet, and we're talking about the Jonas family. Aren't they singers? I really like them. Yeah. The Jonas family had a really busy day. After leaving their home, Mrs. Jonas dropped son Cody. No, that wasn't his name. He wasn't one of those singers. At tennis practice. She then drove daughter Kristen to her soccer game and stayed to watch. After the game, mother and daughter picked up Cody on the way home. Once home, Mrs. Jonas saw that they had driven 20 miles that day. How far are the tennis courts from home? I think a better question is, when in the world are they going to get some dinner? Did she bring it with her? 20 miles, that's crazy. And why are these people playing tennis and soccer? When did they do their math homework? I mean, there's so many other questions to ask. What kind of car does she drive? Is it a van? Because that gets really bad gas mileage. I don't know, maybe it's a big truck. That's even worse. Let's think about the math. See, don't you miss Mrs. Golding? Okay. Let's look down here. It says we can use any method to find the distance between the tennis courts and home, and then we're supposed to set up an equation, and solve it with one variable to find the distance. Here's the stick. The family car can only travel along the main streets, or the grid lines. Okay, so that's where we are. Here's our grid lines. And all the distances between cross streets are the same distance, from here to here to here to here to here. Assume Mrs. Jonas took the most direct routes to and from her destinations. Okay, here's what she did. Mrs. Jonas gets in the car. We're going to say she packed some food because they're going to be hungry. I would be. Go from home to tennis to drop Cody off. Now, to get up to soccer, she can either go up, over, 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 or over, 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 up. Either way, it's going to be the same. So we'll just do it this way. Let's say from home to tennis is a distance of x. Remember, algebra, they like to use x for something you don't know. Well, the problem told me that every one of these streets is the same distance, so that means this has to be x, this has to be x, this has to be x, this has to be x. So we're going to say she took this the lower route to soccer instead of going, okay, it's the same. So we know that this whole distance was equal to 20 miles. I think we could say then, let x represent the distance in miles from home to tennis. That's true. That's how we can define our variable. And we know that there are 1, 2, 3, 4, 1, 2, 3, 4, 5. 5 x's is equal to 20 miles. 1, 2, 3, 4, 5 x's is the same as 5 x's is equal to 20 miles. So 5 times some distance is equal to 20. I know 5 times 4 is equal to 20, because if I divide both sides by 5, which is the inverse operation, instead of multiplying, I'm going to divide. 5 divided by 5 is 1. 1 times x is just x. That's the identity property. X is equal to 20 divided by 5, which is 4 miles. What does x represent? Is the distance in miles from home to tennis. So the distance that Mrs. Jonas traveled from home to tennis was 4 miles. 4, 8, 12, 16, 20 miles. What did I do wrong? Can you find my error? Find it. Find it. Find it. I'll meet with you again in just a minute and we can figure out what I did wrong.